So we're going to talk about variables and measurement. These are important concepts to think about because the variables are a part of how we measure things. So I want to talk really quickly about cookies. And you say, why are we talking about cookies? Well, because I really love cookies and you understand cookies. And we think, well, why does that matter? Well, because cookies go through a process and they can take a whole bunch of different component parts. And you take these component parts and you go through a process and then it turns out to be a cookie. So some of the component parts of every cookie include like a fat. This could be an oil, a shortening. You could use avocados in it. Like you have to have something that makes it rich and helps puff up and separate. Butter is also a fat. You need a binder. Sometimes that binder could be like an egg. You can use other binders. Like if you make no-bake cookies, you boil that oatmeal and it kind of clumps together between the sugars. You got to get something to stick it together. Sugars, you have to make something sweet out of a cookie. So you need some sort of sugar. You need like a white flour or a brown flour. Sorry. Sugar, white sugar, brown sugar, light sugar, dark sugar. You could use agave syrup. You could use honey. There's all sorts of ways that we can add sweetness to cookies. But you're taking sweetness and you're saying sweetness is, I can do this a variety of different ways. I can add this kind of sugar, this kind of sugar, this kind of sugar. And the molasses, you can add every kind of sugar that you add is going to make it slightly different. You use some sort of flavors. Maybe that's vanilla. Maybe there's chocolate chips in there. There's a variety of different kinds of flavors. Amaretto flavor. You can add all sorts of flavors to cookies. Thickener, like body, oatmeal. You could use flour. You could use almond flour. You can use, all sorts of these different things. You got to have it something to stick it to. You need some sort of leavening to puff it up. That could be baking soda. Sometimes the flour or the other thing has some sort of leavening in it. You take all these things, you mix them all together, and then you have some sort of process. That could be baking or boiling. And every one of those little component parts can be done a different way. So the fats can be done a different way. You can have a different ratio between the shortening and the butter, or you could have only butter. You could have only avocado. I mean, there's all sorts of different things. The different ratio of different kinds of sugars or sweeteners. So you have these components, and you can do them slightly different ways. The process can also be done different ways. We can bake it for a certain period of time. We can boil it. You can, oh gosh, I don't even know how else you would cook bake. You do cookies. If you mix it for a certain period of time, it might make it fluffier. Maybe you have to separate the whites from the yolks and the eggs and fluff up the whites first. So why am I talking about this? Because it's just like research. You have this component part and you can measure it a certain way. But ultimately, like sugars, you can do it with brown sugar or white sugar or agave syrup, whatever. Each one of them, however you do it, is a representation of that sugar, and they all have different kinds of flavors. The other thing I want to talk about with cookies is that when we think about a great cookie, we might say, well, I really want it to be sweet, or I love it when it's chewy. I love it when it's fresh. Well, how do we define what fresh is? How do we define what chewy is? We have to sort of create a construct of what these ideas are so that we could go out and like measure it if we wanted to compare. So in the same way that we have sort of like a construct or a component part like chewy, we have to measure it a certain way. We have fats, we can have it, done a certain way or the other. All these choices that we make in research are just like making cookies. If we go back to the research process, let's say we were trying to figure out, sustainable development. Well, what the heck is sustainable development? We have to figure out what sustainable development means before we can sort of figure out how we might narrow it down to measure it. So it starts with this conceptual definition. Well, could we define what sustainable development is as compared to something that's not sustainable development? Or what about sustainable development as compared to sustainable preservation? Well, development involves, maturation. Maybe it involves usage of resources where preservation is not. So we have to figure out what sustainable development is, and then we'd have to figure out like how would we take that and measure it to see if maybe countries or corporations were pursuing that sort of goal. We have to define that concept pretty well, and then we'd have to figure out how to measure it. And the figuring out how to measure it is called operationalization. We take the concept, we make it measurable through an operational definition. That's to say, we look at sustainable development if it meets the needs of now while planning for the future, or however that is. You'd have to be more precise than that even. What does the future look like? Future forever? Or future for 10 years or 5 years? For everyone or just for a narrow group of people? You'd have to write that into your operational definition. Once you have an operational definition, then you can have measures. You can actually go out and measure things. So measurement is key in research. You have to start with this concept. What does the concept mean? How would we define that? And then we'd have to figure out a way to go out and measure it. So conceptual definition, operational definition, and then we have to do a measurement strategy. Now we go out and we try this measurement strategy. We're like in the field trying to collect data because we're following this rule about how we're going to measure. We might collect the right data, but no matter what data we get, that data will never tell us if we're measuring the concept that we're trying to measure. I was on a mine in New Mexico, and we were trying to figure out if soil could grow things. And the way that they were operationalizing that was a specific ratio of electrical conductivity and sodium absorption. So if the soil tested in a certain way, then they would allow us to try to grow things on it. And we were out on the mine and we said, well, here's the problem. We see things growing in places that technically they should never grow. So if they want us to be able to grow things, conceptual definition, like usable soil, but their operational definition, which is this ratio of sodium absorption ratio and electrical conductivity, if that's not actually matching what they're trying to get at, could we figure out a new way to collect data to show them that we can meet the goals of the operation because they're without having to use this operational definition? So what we did was we were sitting around this table and we've got all these consultants, people from Bureau of Land Management, people from Office of Surface Mining. We've got people from the Navajo Nation. We've got people from the EPA. We've got all sorts of people sitting around. And we were saying, look, you can grow the stuff. And they're saying, but the soil isn't suitable to grow stuff. And I say, well, your definition of what suitable soil is doesn't match with what you're trying to get at. And so we walked them back from their measurement strategy and from their operational definition back up to the bigger concept. And we could all agree on the concept, which was we wanted people to be able to grow plants there. And I said, now what if, instead of measuring it this way, what if we measured it a different way, like going out and sampling soil where we actually see plants growing, or having a test plot where we can put bad dirt in there, bad according to your measurement strategy, and see if plants can grow. And turns out we did, and plants grew, and they revised their measurement strategy because what they were measuring didn't adequately reflect their concept. Something was wrong in their measurement. So measurement relies heavily on understanding what you want to measure. What's the concept really mean? And then turning that into a workable definition. That's called operationalization. So both of those parts are really, really important because trying to get that concept right so that everybody agrees, this is part of the concept, that is not part of the concept, this is what this really means. Like once you get that, then you move to something that you can say, well, if I want to measure it, how could I measure that concept? If you don't have a clear conceptualization, then you'd go out and you measure, and you're measuring like bits and pieces, but you might be measuring error too. So let's think about this as like a conceptualization exercise. There's a really common term like sustainability, or you could do health impacts, waste reduction, environmental justice, inequality. Like those are kind of big concepts. Like what does sustainability really mean? Well, we'd have to figure that out. We'd have to say, well, what's the time frame for sustainability? Forever? For who? Sustainable for development, for preservation? Because, honestly, Darwin knows that natural selection happens, and some things like endangered species, even without humans, they're going to die because they can't compete. Should they be able to stay alive over, multiple generations? Like, should we artificially create ways for them to stay alive if they would have died out? Is that sustainable? Is that not sustainable? Like, where does that fit in that concept? So you have to get that thing sort of settled. So the way you do that is you start writing it out. Sustainability means this. And if you had a second, you would sit down and you write, sustainability is this. And you'd read through that and you say, well, okay, what is sustainable? What is not sustainable? Does this thing that I've just written cover a broad range of meanings? Or is it pretty narrow? Would I be able to define what's inside sustainability and what's outside of sustainability? In other words, to say what's sustainable, what's not sustainable. just based on my definition. Well, the Brundtland Commission has a really long-term impact because they set a definition of sustainable development. But it's still pretty nebulous. It sort of gets at the concept, but going out and trying to measure that is actually going to be really, really hard. So we'd say, how do I take that Brundtland Commission definition of sustainable development and say, well, how could I make that measurable? So meet the needs of today without compromising the ability of the future. Okay, well, what does that really mean? How would I see that in practice? What would be sustainable development? What would not be sustainable development? And we write rules. This is sustainable development. That is not sustainable development. And you have to kind of work at what those things particularly mean. Now, once we've taken that concept, we figured out what it was, written some rules about how we might be able to measure that, we have to check to see if our definition is valid. So I'm going to skip out of sort of environmental science, and then we can talk about anger. I've got little kids, and I've wanted to see whether or not you would easily be able to distinguish if a kid is angry. And most of the time you would look at like their face or their behavior. You might say, well, they're punching somebody, that's angry, or, they're yelling. But I've had children, when they got angry, they went over to hug somebody and they hugged them, but they squeezed the heck out of them. You say, well, how would I code that? Is that angry? Is it not angry? Well, hugs are generally not angry, but the way that their facial expression is, like, you can tell that they're angry even though all the outside of what's going on doesn't have the same characteristics of anger, like by hugging. So we'd have to figure out, like, how would I code that? How would I measure that thing? Well, there are a couple of ways to check if our measurement scheme is valid. In other words, it's representing the concept we're trying to measure. Well, on its face, face validity means if I read through the measurement strategy and I think about what the concept really means, does it make sense? It's like the easiest way to do validity. On its face, does it represent it? Okay, well, maybe. What about predictive validity? If I see this thing, does it show me in the future what's going to happen with that other concept? Or does looking at that indicated measure show me what's happening with that concept? So predictive validity is the measurement happens either before or during a change in the concept. We call sometimes these leading indicators. And then another way to think about validity is, so predictive validity is a lot about, does the action end up showing a change in the concept? Is it related to these changes? Now, convergent and divergent validity are about being able to separate the concept from other concepts. Once again, I'm going to step out of environmental science for a little bit, but you'll get this if you work in a regulatory environment, if you're being regulated. A regulator will come in and check your facility, and sometimes they'll let you get away with some stuff, and sometimes they won't. And we call that discretion. That's to say the regulator has some authority to make strategic decisions about what's sufficient enough to fine you or to stop you in your behavior or to correct you. And some of these regulators are very, very, very strict, and so they don't exercise a lot of discretion, but some of them exercise a lot of discretion. So if I'm trying to figure out, like, how would I measure discretion, I would have to write a measurement strategy that would also be able to help me separate discretion from corruption. Corruption happens when, corruption happens when the regulator is behaving in a way that either can be paid off or could be using their discretion to favor certain groups over others. You could also think about that as like discrimination. If the regulator is penalizing one industry or one group of people instead of another group of people, like if there's a systematic way that they're exercising discretion to benefit a group or to benefit a specific company only. So as I'm thinking about discretion and how regulators behave, I would have to write a measurement scheme for discretion that would allow me to say this sort of behavior is just discretion and that sort of behavior is corruption or discrimination. And that's called divergent validity. This concept measured this way, my measurement scheme allows me to separate this concept from this concept. Convergent validity is the same sort of thing. Does my measurement, but except it's exactly opposite. Are these couple different measures allowing me to measure the whole of a concept? Because as you're measuring some concept, most of the time you can't measure all of the portions of the concept. You can only measure a little bit. And you start from this very broad concept and you sort of figure out what you can measure and how you can measure it, but you can only measure a part of it. And so convergent validity would say, well, this measurement scheme and this measurement scheme measure two different component parts of the same concept. So those are some checks on validity. Validity is the extent to which the measurement scheme matches your conceptual definition. Now, reliability is different. Reliability is the consistency with which that measurement will be precise or repeatable. So a repeatable procedure a measurement is said to have reliability if it would give us the same result on the same unit of analysis under the same conditions during replication. In other words, if I'm measuring this one rock, I measure it this way. I come back the next day, I measure that same rock the exact same way. I come back the next day or 3 hours later and I measure and I measure and I measure and I measure. If my measurements are consistent, then I would say that my measurement scheme is reliable. A different way to think about that is, imagine I've got a measurement tool and somebody else has a measurement tool and somebody else has a measurement tool, and we all measure the same rock. Our measurement tools would be reliable if they all gave us the same measurement. Now, if you've ever had a tape measure that's metal, a tape measure that's plastic, a tape measure that's cloth, they're supposed to be all the same, but each of those different substances have different levels of stretch. They're affected by heat. They all have different things. The markings could be slightly wrong. So we have to recognize that the score of the measured score that we get represents the truth plus probably a little bit of error. And a reliable measure will minimize the amount of error and consistently try and get us closer to the true score. So this is one of my favorite demotivational posters. It says, consistency. It's only a virtue if you're not a screw up. And in this one, we have a picture of something that is reliable, but not valid. Valid would mean you would be measuring the concept pretty much on. You'd be that middle picture. A valid measure would be hitting on that target in the middle of the concept. But like in the middle picture, it's scattered. It's not very close to hitting the same spot over and over again. What you want is the picture on the right, which is both reliable and valid. That's to say, your measurement is measuring the concept very, very close to the core of the concept, and it's very, very repeatable. It's very, very reliable. Unfortunately, sometimes we end up with measurement schemes on the left, which are reliable but not very valid. In other words, you can take the same measurements and you'll get the same sort of measurement scheme over and over and over and over again. You'll get the same sort of results, but it's only measuring a portion of the concept, or it's not hitting that concept on its core. So what we want to do is balance these. We really want to get the best balance of being reliable and valid in all of our measurement strategies. Now, when we go to think about how to measure, and we're trying to figure out how to take our measurement scheme and put it onto paper so we can analyze it, we have to remember that there's 4 different levels of measurement. And they on your screen, they go from the least precise to the most precise. Now, not all information can be categorized at the most precise level. But it's important for us to think in terms of our data gathering as trying to figure out a way to get to the most precise level that we can, that will be reliable and consistent and valid. So the first level of measurement, the most broad, is called nominal. Nominal levels of measurement, or nominal variables, are categories or characteristics. Male, female, race, religion, subtropical climate, tropical climate. They're essentially just different kinds of categories. And you can't really rank them. They just are or they're not. Republican or Democrat, whatever. But you can't rank order them. Ordinal variables are a little bit more precise. They're categories that can be rank ordered. So I think about grades. You think about grades. A is better than B, is better than C, is better than D, is better than fail. So we know that A is better than C because B is better than C and A is better than B. We can rank order those categories. Now, within those categories, you could have a variety of different scores on your exam. but you know that that exam score falls into a certain category. In the same way, a lot of survey questions will ask, what is your age group? They don't ask me my age. My age would actually be a ratio level measure. But instead they ask me in this category, and if I fall in this category, then I'm older than this category, and I'm older than this category, and I'm younger than this category. So ordinal level variables are things that can be categorized, and you can rank order those categories. That's more precise than just a name. Now, the more precise way to do that is interval. And the difference between interval and ratio is really about what 0 means. So I'm going to clump those together. Interval ratio data are essentially numbers with known distances separating units. That's to say, like a 1 pound difference, if I'm 200 pounds and I gain 1 pound, that's 201 pounds. That 1 pound is the same as if I were 99 pounds and I gained a pound and now I'm 100 pounds. The 1 pound unit doesn't change across the range of the spectrum. That's interval level data. Okay, now what's another one? Speed. If I'm going 95 miles an hour and I go up to 70 miles an hour, that's 5 units. If I go 80 miles an hour, now I'm going up to 85 miles an hour, that's 5 mile per hour units. Those 5 mile per hour units don't change if I'm going from 65 to 70 or 85 to 90. Those 5 units are the same size units. Okay, now interval level data doesn't have like a fixed 0. It's an arbitrary 0. So 0 degrees Fahrenheit, 0 degrees Celsius, that 0 is arbitrary. It's not exactly arbitrary. It's the coldest they could get at the time, Fahrenheit or Celsius. But let's say, for example, if the 0 is absolute, like I weigh 0 pounds, then that would be ratio level measurement because 0 is the complete absence of, in this case, pounds. 0 Kelvin is actually a ratio level measurement for temperature because it means there's 0 movement inside that molecule, right? It's absolutely cold. Nothing moves. Movement, is related to heat. So it doesn't really matter between interval ratio. You don't really need to know that, but you do need to know that there are 3 levels of measurement, 4 levels if you care. Nominal, ordinal, interval ratio. Okay, so let me tell you another principle about this too, is that you want to get the most precise that you can, interval ratio, but sometimes it doesn't lend itself well to that. You can always take the most precise level of measurement and make it less precise. Let's say, for example, my income, let's say I make, $70,000 a year. That could be, that's a ratio, dollar value. And then if we wanted to, figure out what category of income I went, I could put that in a certain bin. I make between $60,000 and $80,000 a year, which is more than the $30,000 to $50,000 a year, which is more than the $0 to $30,000 a year. So we can take interval ratio level data and make it ordinal, and we could even make it nominal. Am I above a certain level or below a certain level? Or am I poor, am I not poor? Same thing would work with grades. Let's say the last test you got was like an 85. An 85 is a B, and a B is passing the class. So we've gone from interval, 85, to a category, ordinal, that can be rank ordered, to nominal, pass-fail. So we can always be less precise if we get more precise information, but we can't be more precise if we get less precise information. Like if we say, what is your race or ethnicity? Nominal. Okay, well, I can't rank order that. Doesn't make any sense to put one category over the other when it comes to race. That would be ordinal. And it doesn't really represent well to an interval or ratio level data. Like you're a 1, you're a 5, you're a 7, like don't really know what that means. So different levels of information, different levels of measurement provide different types of information. You cannot infer from a less precise measure to a more precise measure. We just went through this. Did you pass your class? What grade did you get? What score did you get? So pass would be nominal, grade would be ordinal, score would be interval ratio level data. You can go from score all the way up to pass, but you can't start at pass and go figure out what your score eventually was. Okay, the other key part is that the type of measurement, the level of measurement that you do will set you up for the types of analyses you can do later using statistics. So let's take the least precise measure, nominal data. You cannot generate an average. You cannot generate a median, like the middle number. There's no middle. in nominal data. But what you can do is this one shows up most in the data. That's a mode. On the other end, on the interval level, you can generate an average, a mean. You can figure out what the middle number is, the median, and you can figure out what the mode is, which number shows up the most often. That's interval level. In ordinal level, can you figure out the mean, an average? No, because you have categories and you can't really what's the average of the categories? That just doesn't make any sense. But what you can find is which is the middle category, or how do the data fall out in those categories? That's the middle, the median. And you can figure out which category shows up the most. That's the mode. So when you're thinking about designing research, you have to figure out how you're going to take this concept, operationalize it, make it a measurement scheme. Is that measurement scheme going to reflect the concept? And is it going to be measured at a precise enough level to do the kind of analysis that I want to do? So moving farther, it's not even on this slide, but with means, interval level data, you can do things like t-tests. You can run regressions. If you're going to do something like a median, like an ordinal level data, you have to use non-parametric statistics because it's not based on a mean. With nominal data, you can do some sorts of non-parametric statistics, but your ability to estimate relationships that are really precise goes out the window when you use nominal and ordinal data. If you use interval level data, then you can do all of the non-parametric statistics that you would do with ordinal or nominal data, and you can do additional parametric statistics based on the mean. So choosing a measurement is not just also which is the most scientific or the literature uses the most. Measuring can be political. Like if you read the chapter on measurement, Deborah Stone says all sorts about why we choose to measure things the way we do, like unemployment. You should also try to figure out what kind of measurement schemes are being used generally and whether or not they have some strengths and weaknesses. The literature generally knows which are acceptable schemes. I'm going to shift over here really quickly to show you some measurement schemes. So I posted this site on the Canvas. It talks about University of Idaho's College of Natural Resources, Principles of Measuring and Assessment, Ecological Monitoring. This will go through all these different protocols, how you measure plant density. There are plot and quadrant types. There are line plots. There are area plots. When you're talking about biomass and production, you have to clip things. Do you directly measure? Do you use destructive measures? Do you weigh things? Do you do line-based plots for coverage? Do you do plot-based? Do you throw hoops? There's all sorts of different ways, and you can look through all of these things. And they all have different strengths. I'm going to show you a different set. Ones that you might not even think about. The Army has to measure its vegetation because it has massive amounts of land, but they also have to be in compliance with environmental laws, and often the EPA ends up suing the Army for non-compliance. So the Army has a whole set of methods, which is also on your Canvas. It's called armytable.pdf, about how you measure data using all these different kinds, and it'll tell you which kind it's intended for, how it's described, here are its strengths, here are its limitations, here's a reference to find it. And there's pages of this. Okay, this is a description. This is how you're supposed to use it. This is what its strengths are. These are its limitations. And you think, well, that's not all that important. Totally it is, because some of these have massive errors. If it's measuring certain densities, they perform well on different kinds of plants, different kinds of vegetation densities. Some of them measure cover better than others, and you want to make sure that you're using the right one for the right application. I've also posted this. It's for the Bureau of Land Management. It's an old methodology handbook, but it talks about essentially how to do this kind of work on Bureau of Land Management, the BLM areas. So I'm trying to find the table of contents. So this one will say, it gives you an overview about how to monitor plant populations, how you, which priorities you have to manage for, how you're going to manage them, how you're going to sample, the different ways to do sampling, different types of sampling approaches, errors from sampling, non-sampling errors, sampling distributions. Essentially it's saying there are methods that we need to use for BLM lands that are applicable here. So chapter 8 is video photography, remote sensing, population counts, densities, frequencies, cover. There are all sorts of different ways, and like I said from the Army one, they all have strengths and weaknesses. So you've got to find the right technique that'll maximize the strengths and minimize the weaknesses in your measurement strategy. Just to show you again, the Forest Service has their own different approach. And these were written, once again, a little bit older. They have the estimation formulas. How do you do it? Tools of the trade. How do you sample? Discrete variables, accuracy, multi-level sample, multi-strata sampling. There's all sorts of methods out there that we should at least pay attention to if we're going to choose a measurement strategy. If we're going to go out and do this work, let's do it right. Now, if all of these things are not adequate ways to measure something, you need to propose something new. Okay, well, how do you propose something new? You have to know every other way, or at least the vast majority of other ways, what their downfalls are and why your measurement strategy is better than every other one or overcomes some significant deficiencies in the other ones. Then you have to justify like crazy. You're just going to have to argue that yours is the better one. The better way to argue is to say, look, I measured using this, the old way. I measured using old way number 2. I measured using old way number 3. And I measured this same site using this new measurement strategy, and this new measurement strategy matches up better with our conceptual definition than these other 3 did. So measurement is not just political, because yes, we choose to measure in certain ways, and we'll show you some of that in just a second, but also it's technical, and choosing the right one to represent that concept is really, really crucial. Now, there's some other potential problems with measurement that you should be aware of. They're called ceiling effects and floor effects. These are range effects. So let's take, for example, you want to measure annual income in a household. And we have this measurement system here, 0 to 30, 30 to 45, 45 to 60, and over 61,000. If you are measuring a town in coastal Louisiana, chances are that might be an okay measurement strategy. That might be an okay ordinal categorization, ordinal level data. But you will probably end up with a floor effect. That's to say, the majority of your respondents, if not all of your respondents, are going to go in that $0 to $30,000 income range. Why? Because they're tending to be very, very poor. Now, let's say we're going to use the same measurement strategy for annual household income, and we go to a place like Newport Beach. You're going to have a ceiling effect. Every one of those people who live in Newport Beach are going to make over $61,000. What does that mean about your measurement? It means that the way that you've tried to approach household income doesn't adequately reflect the variation among your population. So you should put in different bins those income variables to better represent the variation that you're looking for in your sample. So ceiling effects are when everybody shows up at the very high score, and floor effects end up showing up at the very low score. So be careful about how you choose your measurement strategy. Now, here's some other problems. You might have instrumentation issues, precision. That's to say, here I've got this electrochemistry model 250 electrochemistry meter. It'll tell you how close to accurate it can get, plus or minus a certain range. Now, if you are trying to detect within 0.2, but your instrument can only detect within 0.5, you don't have an instrument that's precise enough to measure the difference that you need to measure. So like you wouldn't use a 1 liter bottle to measure 10 milliliters because just the disc on top of the water surface could be a couple milliliters. You want to use a graduated cylinder that's going to be better at measuring 10 milliliters than a 1 liter bottle. So the precision of your instruments can be a real problem if you're trying to measure things. And interestingly, this happens a lot with regulation. Most lawmakers will propose regulation that our instruments can't measure. So we have to develop new ways to measure these tiny variations. The other thing is that instruments wear out. We have to calibrate them. We have to make sure that they're measuring what we want them to measure, that they're not wearing out over time. Like I've got a scale in my bathroom that's 20-something years old, and I'm pretty sure the spring is wearing out. So maybe it's not measuring me the same way as it did before. One way to calibrate is, to use a sample that is a certain density, salinity, whatever it is, and you measure that thing over and over and over again to make sure your instrument isn't, waffling on it or very changing in variation. Now, if you're doing social science research, you have to do what's called inter-rater reliability checks. That's to say, two people who are observing the same behavior, we verify that they're measuring the exact same things. How do you do that? You have them measure the same thing and you compare what their scores were. And you do this pretty routinely. Like every 10 things that you measure, you go back and check to make sure that they're not off. So that can be a real problem for measurement. Now, scale matters too. We're all really familiar with the Richter scale. This is not interval ratio data. Even though it's numeric, it's logarithmic and it's not linear. So these 1 unit changes are actually 10 times. So scale matters, how we present information, how we measure things. Also, we talked back about why some kind of measurements are political. Miles per gallon is really a stupid measurement. And everywhere else in the world, they measure gallons per 10,000 miles or liters per 10,000 kilometers because it tells you how much gas you're using over a certain distance. Well, miles per gallon is how many miles can you go on a gallon of gas. It sounds like it's the same, but you flip things. The problem with it is that miles per gallon, mentally when people hear it, they think that 1 mile per gallon is the same across all the range of the units. In other words, 1 mile per gallon between 10 and 11 miles per gallon is the same mile per gallon as 40 to 41 miles per gallon. And they absolutely aren't in terms of the amount of gas you're using. So let's say down here, you have a 10 mile per gallon car, you're going to use 1,000 gallons of gas plus to go 10,000 miles. And you go up to 15 miles per gallon, you're going to save, was that 400 gallons maybe per 10,000 miles. That's a 5 unit mile per gallon change. You go down here to be like a Prius, go from 40 to 45, that 5 mile per gallon change is like 20 gallons. And so a change down here at these really high levels of fuel efficiency is very, very, very small in terms of gas savings when compared to a 1 unit change down here. And we just don't think about that. And the reason we don't think about that is because it was a concerted effort in the 1970s when the Clean Air Act was established and the CAFE, the Corporate Average Fuel Economy Standards, were being implemented, that we measure miles per gallon because the U.S. auto industry was down here in the lower end of the range, and the brand new manufacturers out of Japan were bringing Hondas in that were getting such greater gas mileage, and we're having a fuel shortage. So it made our American cars not look as bad compared to the new Japanese cars as they actually were. Now, most of the world has flipped. They don't use that. They use gallons per mile because then you can say, well, this is how many gallons I'm going to use over the course of an estimated year. And then then they can calculate potential, CO2 costs and air emissions and air quality stuff based on how many average miles people drive and how many gallons their cars are going to use per year. Is it the exact sort of same idea? Yeah, except one is designed intentionally to hide the impact of your fuel consumption, and the other one is designed to better represent how many gallons or how much your fuel consumption is over time. So how you present information is also really key to measurement. So if you look at here at health risks, this is 3 deaths per million people. That could be represented as that or P.000 or whatever 3. Which one is more user-friendly, reader-friendly? Of course, it's the first one, 3 deaths per million people. If you use the other one, it can hide the information. Another way to present your measurement or your results is to provide a scenario. So you could say what the average is or what most people do, but sometimes an exemplary case where you go and you build like, this is what this organization did, or this is what this sampling showed us, and then you show us a picture, you describe an exemplary case. Sometimes presenting information in a scenario helps us get past some of the measurement problems to see the bigger concept. Another way that people hide information that you should be aware of is in percentages. Percentages are really good for allowing us to make comparisons between percentages, but they also mask information. Let's say we only have a sample of 3 people and we say 33% of the people did this and 66% of the people did this. Wow, that's a 33% jump. Well, how many people had to change? 1. So you don't want to hide information in percentages when you should probably be sharing it numerically. Percentages could also be very, very helpful, though, if you have something that should be compared. So no matter what, though, never gather data in percentage form. Gather the raw data, and if you want to change it into a percentage, change it into a percentage. But it's harder to gather percentage and then change it into raw data unless you've already gathered some raw data for either the count or the baseline number in the denominator. So all of those things are pretty crucial in terms of conceptualization, operationalization, measurement, validity, reliability, measurement schemes, strategies, and how to present information.